This is the start of chapter 16 on trigonometric functions. You'll find it on page 252. We're going to look at a way to measure angles in radians. Before we've looked at in degrees, and this time we need to work in radians because in calculus the calculations, for example, area under a curve has to be, if it's a trig function, has to be worked out in terms of radians. And what we have to consider is if we have a circle which has arc length r and a radius of r, then the angle that we have subtended, which just means supported by the arc, is actually 1 radian. So that angle in there is 1 radian, which is shortened to rad. And you'll see that on your calculator as well. It looks, it says an R up at the top, and you go into your mode to change that. That's at a centre O. Okay, if this angle was to sweep all the way round in terms of 360 degrees, it would be 2 pi radians, because the circumference of a circle is simply 2 pi r. That means that we can do this conversion, that pi radians is equal to 180 degrees, simply because 2 pi radians are equal to 360 degrees. And if we want to convert a radian into degrees, it's roughly 57.3 degrees. So if you feel more comfortable with working in degrees, and it means more to you, then you can see that this angle here roughly is 57.3 degrees, which also means that 1 radian is pi by 80. We say it as pi by 80 radians. Sometimes we don't actually put in rad. We know that if we've got a pi measuring an angle, that is actually in radians. Okay, let's have a look at how to actually convert radians to degrees. If pi is equal to 1, or pi radians rather, is equal to 180 degrees, then this enables us to be able to convert this here, because straight away we've got pi is equal to 180 degrees. If we also think about fractions of pi, we can convert it into degrees quite easily. So another way of thinking about it would be pi by 2 has to be equal to 90 degrees. Pi by 4 would be equal to 45 degrees. And say we had 3 pi by 4. Well, that would just be taking 45 degrees and multiplying it by 3 to give you the answer in degrees. So that would be equal to 135 degrees. We already know that 1 radian, or 1 rad, is equal to 180 degrees over pi. That's what we're saying there. So we can actually convert 7 pi by 15 rad by doing 7 pi over 15 multiplied by 180 degrees over pi. And that works out to be 84 degrees. You can see that at example, it's example 1, and it's on page 253. This time we want to convert degrees into radians, and we already know that 1 degree is equal to pi over 180 degrees radians. So that means if we want to convert 48 degrees into radians, we have 48 degrees is equal to 48 multiplied by pi over 180. So that means that 48 degrees is equal to 4 pi by 15. Now if you have a look at, if you're in maths mode on your calculator, you can actually convert between degrees and radians. You can check your calculations on your calculator to convert from degrees to radians and radians to degrees, and you'll find it at the bottom of your calculator above the ANS button, the answer button. So above that one you will see in a mustard colour DRG with a little arrow on it, forward arrow, and that's the button that we use. We access it using the shift button, and you can change between degrees and radians. We'll have a look at that more closely, but what I'd like you to do is actually try to convert yourself manually the questions 1, 2 and 3, and you'll find these on page 255. This part of trigonometry is really important when we're working out solutions to trigonometric equations, and we use this quadrant system. We call this our first quadrant, this is the second quadrant, this is the third quadrant and the fourth quadrant. And we actually go round in an anti-clockwise direction, and we always start on the x-axis from 0, x, along here, the positive part, and we work in that direction to measure angles. So for example, if we were to put the angles on here, that would be 0 degrees, 90 degrees, 180 degrees, 270 degrees, then back up to 360 degrees. And then if we wanted to go round again, we add on 90, so that would be 450. If we went beyond one revolution, add on another 90, and that would become 540 degrees, add on another 90, and that would become 630 degrees, and then straight back round 2 revolutions would be 720 degrees, and so on. So it's really important that we all measure it from the positive x-axis. So let's have a look at the 2 examples that we've got. In which quadrant would an angle of 540 terminate? Looking at our quadrant system again, it starts off at 0 degrees, then goes to 90, 180, 270 and 360. Then we're going to go back up to another 90 onto that, which is 450, and another one after that would be 540. So just beyond 540, another 20 degrees. So it's going to go round a complete revolution and another little spiral in there. So there's your 540. So it's actually going to terminate, it's actually going to stop in that's the first, second, it's going to stop in the third quadrant. So that one there is going to be the third quadrant. And I need you to be able to draw these quadrant diagrams and actually go round in a systematic way of which quadrant each angle would lie in. The next one's a little bit trickier, simply because we've got, in terms of pi radians, it doesn't mean an awful lot to us at this stage. I would prefer to convert it into degrees, so I would say it's 4 pi by 3, and then multiply it by 180 degrees to convert it, and what does that give us? So remember, that should be over pi, so if we cancel that all down, we should get an angle of 240 degrees. So again, remembering that we've got to go from the horizontal x-axis, so that's our starting point here, and we're going in our anti-clockwise direction. So this starts off at 0, goes up to 90 degrees, then 180, then 270. So 240 is 60 beyond, so it's going to have an angle like that. So again, it's going to terminate, it's going to stop in this third quadrant. I need to emphasise to you, you must be very familiar with this quadrant system, because we're going to use this when we're solving trig equations. Okay, what I'd like you to do then is on page 255, I'd like you to do question 4, and it would be really useful if you draw diagrams. If you draw the quadrant systems, then it would be quite easy for you to actually draw the quadrant grid. It will be easy for you to see where the angle is. So can you have a go at that question 4? So that's everything in exercise 16A to be completed. Thank you. Okay, what would happen if I actually gave you a negative angle? We just looked at positive ones in this example here and here, but what if I gave you an angle that was minus 45 degrees? Well, if you go in the direction of anti-clockwise, we know it's 0, 90 degrees, 180 degrees and 270 degrees and so on. That's if you go in an anti-clockwise direction. If you go in So if you have a negative angle, you actually are going in a clockwise direction. So again, that would be 0, that would be minus 90 degrees, this one would be minus 180 degrees, this one would be minus 270 degrees, and then going one full revolution minus 360 degrees. So that's going in a clockwise direction. We have negative angles. If we look at minus 45 then, it's actually going to lie here, minus 45, and the minus only refers to the direction in which we go from the OX axis, from that horizontal axis. So minus 45 degrees would be in the fourth quadrant, and we still name them as first, second, third and fourth quadrant. How about we draw an angle of minus 195 degrees. So again, we start at the horizontal, which is 0, minus 90, minus 180, minus 270, and back to minus 360. So minus 195 goes beyond this 180 here, goes up slightly, so we're looking for 15 degrees beyond, so I'm measuring from there round, so it's going to be in the second quadrant, and so on. So this minus sign tells us the direction from the OX axis. And that I can't emphasise enough, that's really important when we're going to solve equations.